Welcome to a physics practical walkthrough. You're looking at this because you're preparing for one of the practicals that we do each week, and the idea is that if you've seen it first and you know what we're expecting, it should help you make the most use of your time in the lab. This week we are going to be looking at a density measurements. It's a compulsory experiment, purely introductory, and the idea is that you're going to develop some measurement skills, practice your practical unit conversions, and ultimately the aim of the experiment is to find the density of water and use that density to estimate the volume of a can. Normally you would have to go hunting for your equipment, but fortunately this week we're going to lay it all out. On the lab script we always tell you what you need, and if you don't know where it is, you can always ask, but we're hoping that over the first few weeks you'll kind of learn where everything is in the lab to go and get it. But as I said, this week you get it all on a plate. You'll have to share vernier calipers with somebody. You'll also have to share the pan-top balances. Once you've got your equipment, we expect you to have already read theory, so you know what's going on. You hopefully all remember the density equation from GCSE, and hopefully you've all covered in class how to convert centimetres cubed to metres cubed, because you're going to need that. And if you've forgotten your GCSE geometry, so you've forgotten the volume of a cylinder, we've given it you there as well. Once you've recapped that, you've got the method. We expect you always just to follow the method, do exactly what it says, and to carefully record everything into your lab book. So here's an example of a lab book, and you can see that they've stuck in the initial sheet, the theory sheet, and everything is nicely laid out in tables. So this isn't the neatest lab book in the world, but you can follow everything. It's all really clear. For this experiment we actually give you a suggested format, but in the front of your lab book you've got a list of all the experiments, a suggested layout which we expect you to follow, a little recap on how to calculate uncertainties, and then crucially a CPAC criteria, so that often in your lab book you'll see your teacher say CPAC 4A met, and you'll go, oh, what's that? Okay, I've made some accurate observations. So let's go back to, now we'll look at the method, and we can see that the first thing we've got to do is determine the mass of an empty cylinder, an empty measuring cylinder. So the way we're going to do that is stick it on a pan-top balance and record that. We're obviously making sure that the balance is taired. I'm just going to hit it because it was just a slight residual mass there. Lovely, so that's showing 0. Stick it on, give it a second. That looks like 80.86 grams. So record that into the lab book in the right part of the table. Once we've done that, it says to fill it to the 250 centimetre mark. So we'll do that and then measure the mass of the cylinder with the water. So I've filled this up, and I've been really careful to make sure that get the focus right on this, that when I filled it up I got my eye really level with it, and I made sure that I've taken into account the meniscus and that it's exactly at 250 millilitres, 250 centimetres cubed. And I've also been careful not to spill any water anywhere else on the cylinder. If I have, I've dried it up, and then I've put it back on the balance, and as you can see we now have 329.44 grams. So again, that gets recorded in the right place. There, this obviously was a different measurement, and you've got your next reading carefully written down. You should be able to do all of that relatively quickly. We then take a little sidestep because we're going to use those to calculate the density of water, but we're not going to bother doing that calculation for the moment. We want to get all the measurements done first. So what we now do is take a series of slightly strange looking readings that will record all the dimensions of a can. So the likelihood is you have not used a set of vernier calipers before. I'm not going to try and teach you how to use vernier calipers in this video. There are lots and lots and lots of tutorials online about how to read vernier calipers. There's also a little bit of information on Godomy online and even a little simulation to help you practice. Even a quick Google will show you step by step how to do it. Look, there's other YouTube videos, loads of stuff. So I'm kind of expecting that you would, before you walk into the lab, at least have had a little look at that, so that when you actually come to use the vernier calipers, you've got a vague idea. I'm not going to expect you to use the fine adjustment because cans are hard, so you don't really need to be that careful in how you perform it. But I am going to be careful to make sure that I don't have the vernier calipers at an angle. So I'm just going to open them up, touch them in place, take a reading, and then of course we'll twizzle the can round, take another reading, twizzle it a third time, take another reading. Exactly the same for the diameter of the can as well as the height. I'm going to be a little bit careful here to make sure I don't dent the can. Once I've got the height and the diameter, I'm sorted. So in your lab book, we expect to reproduce these tables whereby you're going to have recorded all of the initial measurements did with the cylinder, also the diameter and height of the can, look 3 repeats, get an average. You're going to make the conversions, keep these in millimetres, chuck them into metres first, makes life a lot easier. Now we've got one more measurement where we're going to measure the mass of the empty can and the mass of the full can. So from that we're going to be able to sort of cross-check what we think the volume of the can is, both with the external measurements just from the vernier calipers, but also with the internal using the volume of the water. So we can fill the can up, and because we're interested in knowing what the percentage volume of the can is going to be, we're just going to fill it up to the brim. Okay, I've actually slightly overfilled it there. Now the problem is any water that you keep in this lip here is going to count to the weight, but obviously won't be full. So what you might need to do is get a piece of kitchen towel and just dry it off, because we don't want any excess weight. The very last calculation you're going to do is what the percentage of the internal volume of the can is compared to the external volume of the can. So stick that on. 357.91 as it happens to be. I'm not going to bother zooming it in. We'd already have taken the weight mass measurement for the empty can, so that we can take away and we can work out what the mass of water is within there. At this stage you've now completed all 3 sections of the method. You've written these tables into your lab book and you should have all of it filled in. A couple of calculations, but they're just very, very simple averages, or one thing minus the other. The next stage of any experiment is to perform the analysis. This particular experiment, we're going to ask you to calculate the density. So we've given you the formula. You've got the values. You're going to be careful to use metre cubed and kilograms. So that should be straightforward. Then you're going to use the averages for the diameter and the height and the volume of the cylinder and work out the external volume of the cylinder. The external volume of the can as if it was just a cylinder. So we're ignoring the fact it's got a dimple in the bottom and all the rest of it. We're just pretending we're making the assumption it's a cylinder. Now, you've got a density of water and you've got a mass of water from the inside of the can. You can now calculate what the internal volume of the water of the can is. Okay. Once you've done that, you can work out a percentage. What's the external volume of the can using those vernier caliper measurements, but also the internal volume using the water. Let's be honest, what's the point of this? It's to get you practicing manipulating data and also let us seeing if you're going to remain consistent with your significant figures and continue to show your workings in a way that other people can follow. Those are really, 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 really key. I'm just going to quickly show you the write-up that someone did from a previous year. So this person, and we'll call them Alex, has put all of their experimental data really, really, really cleanly. Then they've done really well, shown some workings here, and made sure everything is done to what they thought were the correct number of significant figures. They actually made a mistake here. They did 2 sig figs rather than 3 sig figs. They should have carried it through, but they've shown their units really, really well. We've now got some other good workings. I don't mind if you add extra sig figs during your calculations, as long as when you get to your final value, it should always be to the correct sig figs. Now Alex has then done a magic, oops, get in the right place, has done a magic calculation where they've just produced a value. If ever you do a calculation and don't show your workings, especially in practical physics, we're going to be giving you a little bit of feedback to say you've got to show your workings. Hopefully that's giving you a bit of a hint about how you should be laying out your done your method, done the analysis. Always there's some kind of conclusion to be made. You've calculated what the density of water is, so you need to restate it. The external volume of the can was calculated, the internal volume of the can was calculated, and just restate what that percentage of the internal to external volume is. And for this experiment, that's all it is, because there isn't really a theory behind it. I mean, in future experiments, we're going to be calculating the percentage difference between your calculation and what the theory calculation is. Also, we'll be starting to calculate how reliable and how certain this experimental measurements were. So, but that's for another experiment. Today, hopefully you have got a rough gist about how you're going to be conducting experiments, because we expect you to do all the experiments yourself. We'll of course help you, but it's up to you to actually develop those experimental skills. So, hope you found that useful. There'll be one of these videos for each of the experiments, and before each of your labs, you're going to watch them so that you can come in and be as productive as you possibly can with your lab time. Thank you very much.